Section 7-3, this is called rate of change. All right, so vocabulary here is the rate of change, right? So it says a rate of change is a rate that describes how one quantity changes in relation to another quantity. In this case, they're asking you to compare the change in the vertical position to the change in the horizontal position. Now, if you notice, there is a fraction bar right here. So this is a fraction, the change in vertical compared to the change in horizontal. Now, another way to write that is with this triangle, right? So this triangle is called, it's a Greek letter called delta. But in this case, when you use it in formulas, it means the change. So it's saying the change in the y's compared to the change in the x values, which is basically what this says up here. The change in the vertical position is the y values. It's the change in the y's. The change in horizontal position is the x values, because that goes side to side. Now, another way to write that, so you can write delta y over delta x. That means the change in the y's compared to the change in the x's. Or you can write, which is even easier, so this will come up a lot here in the next three sections, rise over run. So the rise, how much is something rising compared to how much something is running side to side? All right, side to side means horizontal, rise means vertical, up or down. All right, so keep those in mind as we start working through a lot of these problems. All right, so example 1, it says the table shows the growth of subscribers to satellite radio. Find the rate of change from 2003 to 2005. All right, so basically here what they've given you 3 years and different amount of 1 million total subscribers. And they're only wanting the change from 03 to 05. So what we don't even really need this middle section for this particular question. So it just wants the rate of change from 03 to 05. Now here's what we do. Right? We just had the delta y over delta x. Right? Delta means, the triangle means the change in the y values. So how are the y values changing? Well, just make this a little bit of common sense here, right? The y's, notice I labeled the y's as the subscribers in millions, and the x's are the years. So the change in the y values, it went from 1.8 to 7.7. That is an increase, so it went up. How much? Well, how do I figure out how much it went up? I hope you realize it's just as simple as subtracting, right? You do a subtraction to figure out how much something changes. 7.7 minus 1.8. If you do a little borrowing here, we should get an increase of 5.9. All right, and I put a positive sign there just because it's an increase. All right, now the delta x is the change in the x values, the change in the years. Well, and from 03 to 05, that change, right? How much did it change? Well, that was a course of over the course of 2 years. So it had an increase of 2 years. From 03 to 05, that went up 2. So that's your change in the y's, that's your change in the x's. To figure out the rate of change, all we do is take this fraction and basically we can divide it or make it a fraction. If we made it a fraction, we'd make it 59 over 20 if we moved the decimal over in both spots. 59 over 20 and then simplified would still be 59 over 20. Or we can just leave it in decimal form, which the book has kind of done, and we just do 5.9 divided by 2. Or if you don't have a calculator, 2 dividing into 5.9. If you divide that with your calculator, you should get 2.95. And then realize if we're explaining what this is, that means 2.95 million subscribers per year. All right, so that is the rate of change. Every year, they're averaging around 2.95 million more subscribers each year. Example 2 says the table shows how the perimeters of an equilateral triangle and a square change as side lengths increase. Compare the rates of change. All right, so this is going to look confusing because in the table that you see, it has 3 different columns. So we're just going to separate this each way. We're going to do a table for the triangle, and then I'm going to make a separate table for the square. And that should make a little bit more sense. All right, so here are the 2 tables. And I just wrote this out, so I reused 0, 2, and 4 for the x's, and I just used it both times. And then I wrote down what the y values were. So it's talking about the perimeter of a triangle and a square. Realize perimeter is just adding up all the sides. So, if the side lengths of a triangle were 2, and there's 3 sides, so the perimeter would be 6. If the sides are 4 in length, and there's 3 sides, 4 plus 4 plus 4 is 12. And for a square, there's 4 sides, right? So if the side of a square was 2 and there's 4 of them, 2 plus 2 plus 2 plus 2 is 8. All right, that comes up over here. And then if the sides of the square are a length of 4, then there's 4 sides, 4 plus 4 plus 4 plus 4. It would give you a perimeter of 16. So let's look at these two tables now going forward. We need to make our delta y over delta x, right? So that's basically like a formula. That's telling you the change in the y's and change in the x's. So we're going to make this simple, right? They've given you 3 points here, 0, 0, 2, 6, and 4, 12, and then the square has its own 3 points. We don't need to choose all 3 points. All we do is pick 2 of the points. It doesn't matter which 2 you choose. But let's just figure out what the change in the y values are. So I'm going to do this using my first 2 points. So from 0, let's move to 6. How did it change from 0 to 6 for the y's? The change in the y's is it went up 6. What's the change in the x's for that same situation? Went from 0 to 2. It had a rise of 2. And all we do is simplify this or divide it. 6 divided by 2 is 3. So that's the rate of change for a triangle, an equilateral triangle. It's 3 units of perimeter for every side length of 1. All right, now let's do the square. Notice I didn't even need the 4 and the 12, right? Because all you need to do is pick 2 points. If I had chosen 0 to 12, that would have been an increase of 12. And then I would have also had to use 0 to 4. Well, that would have been an increase of 4. And 12 over 4, if you simplified it, is still 3. So it doesn't matter which ones you choose. Let's go ahead and use this again. The change from 0 to 8 for the y's, that's a rise of 8. And the change in the x's for that same situation is it went up 2. 8 divided by 2 is 4. That is the rate of change for each of those situations. And example 3 says the data points on the graph show the relationship between altitude and temperature. Find the rate of change. Again, the rate of change is the change in the y's compared to the change in the x's. All right. So on this line, they've given you 2 points. They tell you exactly what they are. One point is 0, 24, and the other is 3, 4.2. All right. You see that on the graph, and I wrote it up here. So what is the change in the y values, right? So here's what you're looking at. The y values in each of these points, and you can look at the graph or you can look here. These are the y values in these points. So let's just do this change from 24 to 4.2. How is that changing? First of all, is it going up or down? It's going down. Since it's going down, the y values are changing at a negative rate. How much is it changing? Again, let's use some common sense here. How do we figure out how much something is changing? We subtract. In this case, since we have decimals, we've got to line up the decimals. We're going to do some borrowing here. Change that. And we get 9 and a 1. So we end up having, there should only be 1 decimal there, 19.8 is the decrease. So it went from 24 down to 4.2 for the y's. So it had a decrease of negative 19.8. That was the change in the y's, the delta y. The change in the x's, the delta x, is the change in the x value. So we're going to do the same thing. How is 0 changing when it goes to 3? 0 to 3, I hope you know that's an increase of 3. That's a positive 3. All right, so that's we don't have to write a separate subtraction for that because we know it. And then all we do, you can see this in the book, they have the same fraction I do. This is degrees Celsius as it's changing for the y's compared to 3 kilometers. So when we find the rate of change, all we're doing is dividing. Just take this to decimal form. In the calculator, it'd be negative 19.8 divided by 3, and we get negative 6.6. Now my units here, and this is important throughout the whole section, my units here become negative 6.6 degrees Celsius per kilometer. All right, so anytime you have a rate of change, really what you're getting here is a unit rate in a way. So you're getting how much this average rate of change is per kilometer. It's changing negative 6.6 degrees every single kilometer. All right, so that is it for this section 7-3. Best of luck.